Hello learners, this class is for second year 4th sem. The paper name is optics and today's topic that we are going to discuss is change of phase on a reflection, or it is also known as Stokes law in waves. Change of phase on reflection or Stokes law in waves. So how is the phase changing due to reflection? Okay, how is the phase changing due to reflection? That is what we are going to see. So this law states that when a light wave gets reflected, from denser medium, it suffers a phase change of 180 degree or pi. Okay, when a light gets reflected from a denser medium, it suffers a phase change of 180 degrees. That is called as Stokes law. So by using phase difference and path difference relation, we know phase difference and path difference relation now. That is, phase difference is equal to 2 pi by lambda into path difference. This we have seen earlier. Phase difference is equal to 2 pi by lambda into path difference. So if phase difference is pi, then 2 pi by lambda into path difference will be the phase difference. Okay. Now let us see with the diagram over here. See, this is a light that has been illuminated. This is some surface, reflecting surface. So some of its light, let me draw like this. So as this light is illuminated, the amplitude of this light is E naught. Okay, incident waves amplitude, let it be some E naught. So what happens next? As soon as this light is incident on the reflecting surface or any surface, some of its part is reflected in this way. Okay, whose amplitude, let it be some E naught R, and some part, what happens, some parts get transmitted in this way and whose amplitude is E naught T. Okay, so partially the light is reflected, partially it is transmitted. Okay, again we have kept some mirror over here, M2 mirror, and here M1 mirror. What happens, again it gets reflected, transmitted in that way. So let this be water, some denser medium we are taking. This is a rarer medium. Okay, this is the way that light is being incident and partially reflected and partially transmitted. Then again what happens, because there are mirrors kept here, what happens is, you see, again this will be reflected back in this way. Okay, and due to that reflection, this acts as an incident wave now, so here it will go like this, here it will be transmitted like this, let it be some E naught R here, no? So this transmitted light will be E naught RT, this one E naught RT, and some part will be reflected in this way, let it be E naught RR, E naught RR. Next what happens, next again here we saw this E naught T in this way, no? It was going in the first diagram we saw like this, right? So this one again, as there was a mirror here, this one will reflect and transmit. So transmit in this way gives us E naught TT dash, and transmit in this way, again on this line only will take. So this gives us E naught T R dash. Understood? So this is the way how the lines are reflecting and transmitting. So I'll explain you again. Firstly, what happened, we are incidenting a light on the surface with amplitude E naught. Then some part will be partially reflected and other part will be transmitted in this way. Reflected and transmitted in both these ways. Now here mirror is there, here mirror is there. So this light, again the second diagram you see, this light will reflect in here, transmit here. And again, as we have seen, this one transmitted, no? This one will again get transmitted in this way, reflected here. Okay, this is the way how they are transmitting and reflecting through the mirrors. So remember this diagram. Now we'll see the theory part. Let R comma T be the reflection and transmission coefficient. Let R T be the reflection and transmission coefficient of rarer medium air. Let R dash and T dash be the reflection and transmission coefficient of denser medium. R and T are the coefficients of reflection and transmission in rarer medium. R dash and T dash are the reflection and transmission coefficient in denser medium. Let it be water. So consider a wave of light amplitude E0 incident at a point O, then the wave is partly reflected along OB with amplitude E0 R and partly transmitted along OC with amplitude or with energy E0 T. Now suppose reflected and transmitted waves are reversed in the absence of any absorption. No absorption is there. There we have kept some mirror or something. So again it starts reflecting and transmitting now. So on reversing, now we get reflected wave with energy BO here. Now on reversing BO, we get reflecting wave with energy E0 R and it also transmits now. So E0 RT is the amplitude or energy. So according to principle of optical reversibility or according to the law of conservation of energy, what we can write? We can write amplitude of incident beam is equal to amplitude of reflection beam plus transmission beam. Amplitude of incident beam is equal to amplitude of reflection beam and amplitude of transmission beam. That is a conserved energy. So E0 T, E0 T T dash, that is incident beam's amplitude, transmission beam's amplitude plus reflection beam's amplitude is equal to incident beam's amplitude. E0 T T dash plus E0 R is equal to E0. This is amplitude of transmission beam, this is amplitude of reflection beam, this is amplitude of incident beam. That should be equal because of the law of conservation of energy. So E0 taking common, we can write T dash plus R, that is equal to E0. E0 cancel, will remain with T dash plus R is equal to 1. Or you can write T dash is equal to 1 minus R means you can write R square. Let this be equation number 1. Okay, understood? Now along OD again, no incident ray is there. That is equal to amplitude of transverse wave plus amplitude of reflecting wave according to law of conservation. So no incident ray is there along OD. You can see in the diagram again. No incident ray, so 0. Amplitude of transfer wave is E0 TR. You see the diagram again. And amplitude of reflected wave is E0 TR dash. Okay, so we can write like this. E0 TR is equal to, send that this side. So that will become E0 TR dash. Here it will become minus, okay, after exchanging. So E0 cancel, T cancel, that will remain with R is equal to minus R dash. R is equal to minus R dash. Remember, R is equal to minus R dash. So negative sign indicates that reflected wave will have phase change of pi. Negative sign indicates that the reflected wave, the wave which is reflecting will undergo phase change of how much? Of pi. Phase change of pi occurs there. So according to law of optics, we have R square plus T square is equal to 1. Okay, and from that we can write T square is equal to 1 minus R square. Let this be equation number 3. Now compare this first equation and third equation. What was our first equation? First equation is T dash is equal to 1 minus R square. And this is our third equation. Now comparing this first and third equation, we can say that transmission wave will not undergo any phase change because there is no sign change, no? So by theoretically, as there is no sign change, we can practically say that as there is no negative sign, The transmission waves will not undergo any phase change, but the reflected waves will undergo phase change of pi. If it is like this, after reflecting it will become like this. So there is a phase difference of pi during reflection only. During reflection only, not during transmission. During transmission no phase change, only during reflection there will be phase change. So this is also called as Stokes theorem in waves. I hope you understood.